All right, here's homework solutions 1.5. This is the back side. We're talking about word problems. So for number one, we've got area. This is a formula you're really familiar with, except for normally for area, we've got area is equal to length times width. But they're saying now area is modeled by this function where width is a function with respect to length. So width would be area divided by length. So if the area is 1,000 square feet, describe the transformation. So let's plug in 1,000 for the area. Here's my function notation, 1,000 over L. So what does that 1,000 do to this function? So this is the same thing as 1,000 over X. So it's outside of my denominator, so it's a vertical transformation. And we're multiplying it, so it's a vertical stretch. I can spell it right. It's a vertical stretch by 1,000. All right, it says describe the parent function of the length that could be used to find a minimum perimeter. So what do you know about perimeter? So we know perimeter is length plus width, or two lengths plus two widths, right? You're adding up all the edges of your rectangle. But we want to write perimeter as a function of length. So that's going to be 2 times my length plus 2 times my width. But here's what my width was, right? Well, here's what my width is in terms of area. So 2 times area divided by L. If I write a function in terms of L, I can't have any W's over here. It's all going to be L's. So 2 times the length plus 2 times the width, but width is defined as area divided by length. All right, and then it says, is the function you found in part B a transformation of f of x? So in other words, let's turn this into x's, because I think we can see better in x's than we do in this notation. If the function was this guy, 2x plus 2a over x, would this be a transformation of the rational function? Hopefully you said no. Why not? Oh, not question mark, no. Reason being because it has a linear and a rational function to it. So it's got two different functions going on, so it can't be the transformation of one or the other. And then finally, find the minimum perimeter for an area of 1,000 square feet. So we're trying to find, the perimeter with respect to L, which would be 2L plus 2 times they want 1,000. So I'm plugging 1,000 in for area here. So 2 times 1,000 will give me my 1,000, 2,000 here, divided by L. I'm going to plug this guy. I'm not the best L writer. I'm going to plug that guy into Desmos. That's my graph. And I'm going to look for a minimum point to it. So I'm having to come pull this up over my computer on the other side. So here's my graph. 2x plus 2,000 divided by x. It's this funky looking rational function. It looks great. We're going to do these guys in the next chapter where it has an oblique asymptote. Oh, it won't let me draw on here, unfortunately. It has an oblique asymptote, which makes it look all funky like that. But hopefully you see the minimum point. Maybe. My minimum point here is at 126.49. So the minimum area that we would have would be 126.5 feet for the minimum of this function. All right. Number 2, we're talking about golf, and the path of the flight of a golf ball can be modeled by this function, where h of x is the distance above the ground in yards, and x is the horizontal distance from the tee in yards, and it asks us to find the transformations. Well, we can tell its parent function is a quadratic, but is this guy in vertex form to where we can see the transformations of the vertex? We can't tell the transformations unless it's in vertex form. This guy here is in standard form. We need to get it into vertex form. How do we do that? So the answer to that is we need to write it in vertex form by completing the square. So I'm going to pull this 1/10 out. That's the first step to completing the square. You might be asking me, why, Miss Harris? Why are we doing this? You're going to have to complete the square big time later. So the more you can practice doing these small tasks now, the better it's going to help you down the line, because this completing the square part is not going to be confusing to you. It's the conic stuff that's coming up that's going to be confusing. You won't be tripped up with the completing the square. So I'm going to pull out the 1/10. And then if I take 1/10 away from this guy, I also have to factor 1/10 out of 2. And you're like, but that's not a factor. You're right, but we can make it a factor. What times negative 1/10 would give you a positive 2? So first of all, if it's going to be positive, I need a negative in here, right? Because negative times negative would give me the positive. And then what times 1/10 would give me 2? That would be 20. 20 divided by 10 gives me the 2. Negative times negative gives me the positive. So negative 20x. All right, so we factored out that a. Now I want to complete the square of what's in the middle. So to complete the square, I'm going to take that negative 20, I'm going to divide it by 2. So negative 20 divided by 2 is negative 10. This is what we're doing right here to figure out what goes up here. Negative 20 divided by 2, and we square it. That would be negative 10 squared, which is negative 10 times negative 10, which is 100. But if I add that here, I can't just add it, that would change it. I need to subtract it off out here. So we've got 100 that we're putting in here, but remember, it's not really 100 because it's also multiplied by this negative 10. So if I put 100 here, it's really negative 1/10 of 100. So I really have to do this. So negative 1/10 of 100 would be negative 10. 100 divided by 10 is 10, and it's negative. So really what I did was I subtracted 10. I'm going to have to add 10 out here. All right, and then I've got my perfect square. This gets me into my vertex form. So what times what gives me 100 adds up to negative 20. Hopefully you see that's negative 10. Negative 10 times negative 10, positive 100. Negative 10 minus 10, negative 20. And then we still have our plus 10 out here. So what are my transformations? First of all, I went not to the left like it says. I have a horizontal shift, right 10. I have a reflection, that's what that negative sign does, reflection across the x. Then I've got 1/10, it's outside of my parentheses, so that's vertical. And it does what it says. It says compress it by 10, so I'm going to compression by 1/10. And then out here behind, I've got another vertical transformation. This time it's a shift, vertical shift up 10. So I know that wasn't the prettiest problem, but it is good practice. And if you can understand that, you're going to be doing so well for conics. If you struggle with completing the square, maybe not right before the test, but come in during tutorials, maybe right when we start some new material, and ask for some help with completing the square, and we'll get you set up. All right, for B, it says, suppose the same shot was made from a tee located 10 yards behind the original. So instead of being at X, so this was my function, but instead of being here saying, oh wait, let's start it at 10 yards behind the original one, so X minus 10. So now, if I plug in X minus 10, oh, sorry. Got to think backwards because we're talking about a horizontal shift. So here, if this was my original guy, and I want to start back here, am I really subtracting off 10? No, I'm going in this direction. It should be negative 10, but remember we need it to be the opposite because we're talking about those axes. So here, when you plug that in, the negative 10, positive 10, oh, I can't forget this guy. This guy down here. So the negative 10, positive 10 cancel each other out, and you just get negative 1/10. x squared, because these guys went away, plus 10, and that would be your new function. All right, these word problems are a little bit lengthy, so I'm going to go ahead and stop it here, so it'll upload to YouTube easier, and I'll do the last two problems on the next video.